everyone, welcome to TigerGraph's video recommendation system built using TigerGraph Cloud, Plotly Dash and Plotly. You can check out the links on our blog site. This application allows you to get your favorite videos based on provided keywords along with the ability to pinpoint where the keywords were spoken in the videos. The dataset incorporates a variety of themes such as finance, cryptocurrency, animals, astronomy, literature, author, etc. You can find dynamic visualizations of video analytics like Cytoscape, topic modeling, and entity recognition.
I will be doing the UI walkthrough now. As you can see on this page, we are on the main page named General Overview. We have three drop downs. The first one where a user can write a keyword or can select from the list of keywords. Suppose I write a keyword named crypto. So on the second drop down, we'll get a list of videos that contain this particular keyword. So if we select one video, we can get on the third drop down the timestamps where this particular keyword is occurring in this particular video. So these timestamps are in seconds. So this is also optional. If I don't select and go at timestamps directly, then the video will start from its 0 seconds. But if I go back and change the timestamp to one of them and I click on that again, and now I see that it is starting from the selected timestamp. So now if I click, so here we have two buttons. The first one is get video recommendations and the other one's to get the video visuals for this particular video. If I click on the get video recommendations button, I get three top recommendations on the basis of the keywords of this particular video. So we got FD mutual finance, we got cryptotex and mutual funds as the three top most recommendations on the basis of that video cryptocurrency. On the other two divs, we have video analytics and the sentiment score of the video that is shown on the card. The video analytics has for the first card we just have keywords, video length and theme, but for the recommended videos we'll have a Jacquard similarity score associated with that as well. And on third div we have the sentiment score that we have got using the sentiment analysis on the transcripts of these videos. Now if I want to go to the second page, that is explore visuals, what I can do is click on one of the red buttons over these cards, or I can directly click on to the left sidebar. Let's go via a video card only. I select this one. So if I select that one, this is coming pre-selected, so we'll be talking about this multi-page functionality in the later part of our video. But if I now select one of these buttons, then I'll be getting the entity recognition and the bar graph as well as the Cytoscape, and these will also be discussed in detail in the later part of this video. Now if I go to the third page, that consists of the topic analytics or the topic modeling that we have done on the transcripts of our videos, and we also have the legend at the bottom where you can select the pertaining topic number for a particular theme. So suppose if I want to go for a cryptocurrency that has a topic number of 6, I find it in the bubbles. So here is 6. I can get the marginal and probabilistic probabilities, the distribution probabilities while hovering on the keywords, as well as I can change the relevance metric using that the keywords and the order changes. We can directly change the topic via clicking on these buttons. And at last, on the last and fourth page, we have the about, where we have how does this work and what basically is this app doing, as well as the contribute and its guidelines, how can you contribute to this project, and in the end the contact details of the externs including me. So in case of any queries you can always reach us. And the left sidebar that we just missed is also containing the blog post URL, the video tutorial link, the collab notebooks and the repository link of this application.
Let's get started. Firstly, we have to set up our TigerGraph solution on the TG Cloud. For that, head over to this website and log in. Head over to the My Solutions tab. Now, we will be creating a new solution by clicking the Create Solution button. For this project, we are going to start with a blank solution. For instance settings, keep everything at the free defaults. Finally, for the solution settings, we can rename our solution to whatever we desire and set up a password to later access it via the unique subdomain which we select. Click the submit button. Now it will take some time to initialize and run our solution. Once the solution is up and running, we can head over to the Graph Studio. Here, firstly, we need to import a solution that the team has already created. This, along with all the necessary data that is required to run this project, is available on the GitHub repository, which is also mentioned in the Medium blog. For this project, we are going to import this solution. So click on the import an existing solution button and click on this file. Don't worry, override the solution. Here, I have already imported this solution since it will take quite some time to load. After the importing is done, click on the global view and select the graph that we need to work upon. Now head over to the design schema. We can see that how all the nodes and vertices are related to each other. Next, head over to the Map Data to Graph tab. Here we have three CSVs which we need to again upload by clicking on the Add Data file and then on the plus sign. These three CSV files are again available on the GitHub repository in the TG Cloud folder. After uploading these files, head over to the Load Data tab. Here we will load the data onto our graph by clicking this button. Hit the Continue button. All that is left for now is to install all the queries that later will be called on our dashboard. So go to the Write Queries tab and click on Install or Queries button. These are all the queries that are going to be installed. Hit the Install button. Our solution is ready and now we can head over to the dashboard. To access the dashboard, go to the GitHub repository. There, go to the Google Colab Notebooks folder. We will be needing the TigerGraph Extern Dashboard Final Python notebook. Click on it. Now click on this button to open the same in a Google Colab notebook. Now before running all the cells, head over to the section 1.2 and make sure that you have entered the same credentials as you have mentioned while creating the solution at the TG Cloud. So double check the subdomain, user, username, password and the graph name. After this is validated, you can go ahead and run all the cells. Now one thing to notice in this notebook is that apart from loading the data directly from the Graph Studio, here from the section 2.1 to section 2.4, various loading jobs have been created to load the data onto the graph. Now I'm going to brief you on one of the major queries utilized in our project, that is the get recommendation query. The get recommendation query takes in a video ID as input. It has a typedef tuple which contains the video audio ID along with its Jacquard similarity score, a heap accum which stores the top three video IDs with the highest Jacquard score, two set accums, one to store the current input video ID's pre-processed transcript and the other one to store the pre-processed transcript of the other videos present in our database. Next, The pre-processed transcripts of the other videos present in a database are traversed one by one, and their Jacquard similarity score, which goes by the name similarity, is compared with the current input video's pre-processed transcript, and the result is stored in the heap queue. Finally, the final result containing the top 3 videos with the highest Jacquard score is printed. For example, let's say we have a video ID 1, and if I run this query, here we can see that I will get the top 3 other video IDs with the highest Jacquard score of 0.129. To know more about this query, head over to our Medium blog. Here you can get even more information about the G-SQL queries. For this section, I am going to explain the chain callbacks that are being utilized in these 3 dropdowns to generate the first video card. When a keyword is selected from the first dropdown, the keyword to video ID query is run that stores all the videos containing that particular keyword along with their timestamps of occurrence in a dictionary. The keys of the dictionary containing all the videos is further fed to the next dropdown as input. Finally, their corresponding timestamps are given as an input to the final dropdown. With all these information along with some metrics, the first video card is ready. For example, first we choose a keyword, then the corresponding videos containing this keyword appears. Here's it's only one keyword. Then the timestamps at which this keyword, that is accounting, appears in the finance. And here we go.
Now I'll be discussing the multi-page functionality and data transfer. That is, if I click on one of the videos, let's just select a different keyword for this experiment. So if I select a video and I want to go and I get its recommendation and I want to go to the second page via one of the divs on the current page. So if I select get video visuals, the chimp is pre-selected on the second page. So the first thing to understand is how the page is changing. The second thing, how the chimp is becoming pre-selected. And the third thing is how only chimp got pre-selected. That is, there were a lot of different buttons. So how did we got to know that which button was selected? So to answer the first one, the page is being changed using the variable path name. So on the path name, so as you can see, the URL is being changed whenever I change pages. So whenever the path name changes over the URL, so we have the ID on that. So if I just go back to the collab and go to dashboard layout, and if I search for path name, so as we can see, the input is URL and its path name. So whenever the path name changes to home, we are returning the dash general page. Whenever it's hitting the analytics, we are returning the visualizations page, and so on. Now how the first thing is answered. Now how the index or the particular video title is becoming pre-selected. So the index value is being set, and we are retrieving it every time this particular callback calls. Why have we declared a function? That is because you cannot change the variables directly at runtime whenever a callback is triggered. Instead, you have to have some getters or setters whenever the callback is triggered, and we can use those functions to update our variable at runtime. Now so we got to know that, okay, using this get index value, we are getting the index value of that particular video that we had selected on the first page, and that is how we are getting the name of the title pre-selected on the second page. But how does the app know that this particular title was selected? So which button got clicked? So this is basically coming from the dash documentation in advanced callbacks. You can definitely head over to that. The same is mentioned in the blog as well, and this also has been explained over there. So to explain you that, if you see just callback above it only, we have four buttons, and we have just we actually didn't want to return anything, so we created a temporary div and we are returning just an empty div. We just wanted to know which button was clicked, so whenever the button 0 is clicked, we are just setting the index value 0, and correspondingly the index value is going till 3. And as you can see, if currently I selected the first one, that is Jeffrey Archer. So if I just go on and show you one more time, so the first one is 0, this one is first, this one is second, and this is third index value. So if I select the third one and I click on it, so the set index value function gets fired up whenever this callback is being triggered. The index value has been set as 3, and on the second page, whenever this page was being rendered, we get the index value, we pass it to the function that is visualizations content. Just to know where all of these contents, where all of these functions are defined, you can always head over to the dashboard components, and you can see, no, we are not on the sidebar, but we are on the main page. So here's the first function, but if we don't want to go to the main page, we can go to the explore visualizations or explore visuals page, and there's your second function. Now the only thing that we missed for the multi-page integration is the titles. So we have them global. Now this is crucial. We have to declare them global outside of the function, but it's very important that you also declare them global again inside the function wherever you are accessing them, because we want them to be global throughout the collab, and whenever that is being changed on, you know, whenever a callback runs and whenever this is being changed at the below part of the collab, we also want it to be changed at the top one where we are actually accessing it. So if a user do not go via the first page and directly clicks on the explore visuals for the first time, then the first one will come pre-selected, that is astronomy, as the index value initially will be -1, and that is being handled on the explore visualizations page. That is, if the index value, that is the default one, is -1, then we won't be changing the values, and that is also being done over here. So if index is not -1, that is the callback where we actually set it, the index value has run up and the index is not -1, so we should get the titles using the index value that we have got, which is not -1 now. So I hope this clears a lot of different things. It is a little bit complicated, but yeah, that was the multi-page integrations and the data transfer that is being happening between them. So now I'll be talking about the JavaScript integrations and how basically whenever we click on the go timestamp button, how the divs that are not being shown on the page right now will show up, as well as when we click on get video recommendations button, we'll get 3 more divs having the topmost recommended videos according to the video we selected earlier. So this would have been done using the dash components as well, and that would be easier than what we did now, but this isn't as well a very hard. This is done because while using JavaScript, it will give us more powers to control DOM, that is document object model. And if I just go back to our collab, we'll see that if I go to the dashboard layout and callbacks, we'll see that on the bottom we have actually returned the JavaScript using a callback. So over here we have a function called name my fun. This gets triggered whenever this callback gets fired up, and this callback fires up whenever the main page content loads, or the n-clicks increases. Now this is done just because we want this JavaScript to run for on the main page, and this JavaScript code is self-callable. As you can see, this is being called on this or on opening the window. So what this basically is doing is every time the go button or the button gets clicked, we are increasing the scroll value of top and left, as well as the behavior is smooth, as you can see. Also, we are showing or displaying some of the divs that are currently hidden and changing their display style to flex. So that is what this JavaScript code is doing, and this callback basically helps in showing and displaying these cards that we have on the main page very smoothly, and this is working perfectly right now.
We have performed topic modeling using a famous topic modeling technique, Latent Dirichlet Allocation, to extract topics from our transcripts. These topics will aid in our visualizations. Once we have imported these utilities, we can go on to the lemmatization of our pre-processed text. We have performed some visual analysis of our dataset through word clouds, unigrams, bigrams, and trigrams. Coming to model building, here we specify the parameters and the number of topics of our model. We obtain the PyLDAVS visualization that we will use on our dashboard to visualize topics and the similarity between them. Each video has been further assigned a dominant topic which relates to its theme. Finally, we will save and export our dataset.
Now I am going to talk about an amazing and highly interactive Dash component, the Cytoscape. Dash Cytoscape is a graph visualization component for creating easily customizable, high-performance, interactive, and web-based networks. In this project, we will have used the Cytoscape to find the relation between a video's theme, its topic keywords, and the videos that they belong to. The usage elements.py hosted on the Dash Cytoscape GitHub repo lets you progressively expand your graph by using the tap node data as the input and the elements as the output. The app initially preloads the entire dataset but only loads the graph with a single node. It then constructs four dictionaries that maps every single node ID to its following nodes, following edges, followers nodes, and followers edges. These dictionaries are later used to expand the cytoscape. Now let me show you a demo. Here we can see that the theme literature belongs to the video astronomy. Now we can begin expanding the cytoscape by clicking on the initial node. As we can see, the nodes further expands into multiple nodes where the blue node signifies the video names and the red node signifies the topic keywords which belong to this particular theme. Now we can also change the layout from the control panel. To further expand the node, we can further click on any one of the nodes, for example let's say sun, and see how the nodes have further expanded. This signifies that these four videos contains the keyword sun. Now what if we click the blue node? As you can see, the node Jeffrey Archer, which is a video name, has attached itself to already pre-existing nodes and also some new nodes, signifying that the video Jeffrey Archer has all these video keywords.
We perform sentiment prediction on our dataset to analyze the emotions of our video. We first get the utilities imported and then we can start with executing Vader on each transcript. Vader is a lexicon rule-based sentiment analyzer. It utilizes a mix of lexicon highlights marked on semantic directions as negative or positive. We compute positive and negative scores for each transcript. Finally, we save these scores. Named entity recognition is a process of classifying entities into predefined classes such as organizations, date, persons. We will use contrasting colors on our dashboard to make this visualization look simple. Term frequency, inverse document frequency, keyword extraction is done to extract important keywords to get a sense of what characterizes a transcript. These keywords can be used as a simple summary of a single transcript, which will aid in our graph. We generate TF-IDF scores for all the documents. And finally, we save these scores. And voila! Your video recommendation system is ready. We hope this tutorial helps you understand the different aspects touched upon in this project. Please feel free to contact any of the externs mentioned in the description in case of any queries. With TigerGraph and Plotly, you can do infinite number of things. Happy exploring!